Okay, continuing on. All right, so what if we're given a graph of a line? How are we going to write an equation in slope-intercept form? So we did a couple of examples of this yesterday, but we could find our y-intercept, or where the line crosses the y-axis. So in this case, the red line crosses the x-axis at, be sure we're counting by ones, 1, 2, 3, 4. All right, so it crosses right here at -2, or that point is 0, -2. So our b is -2. The slope is we go up 2 and over 3, all right? So our slope is up 2 and over 3. So we rise 2 and we run 3, up 1, 2, over 3, okay? So our first step is to find the y-intercept. The second step is to find the slope, or the rise over run. And the third step is to just substitute in. Into y n equals mx plus b. So in this case, our slope was 2/3 and our b was -2. So we would just substitute those in. So this would become the coefficient of x, and this would be our constant. So it would be plus -2, which can be rewritten as 2/3 x minus 2. All right. So let's try another example of that. All right, I'm going to do this one right here. All right, so what is our y-intercept in this case? Okay, it goes through the origin. It crosses both the x and the y-axis at 0, right? So it goes through the point 0, 0, which means our y-intercept is 0. That doesn't mean our slope is 0 though, right? Slope being 0 would be a horizontal line. In this case, we go up one, looks like it goes through this point right here. All right, so I pick my 2 points, and my rise is 1, 2, 3, 4, 5, and I run 2. So I rose 5 and I ran 2. So my slope is 5 over 2. So when I substitute that in, I get y equals 5 over 2x plus 0. But of course we don't really need that plus 0. So our equation is just 5 over 2x. All right. And once again, coming back to another example. All right, let's try this one. So we're going, or no, we already did one with the origin 0. All right, what about right here? So our b is 3, or the point 0, 3. And our slope is, we got to pick another point. Looks like here's another point. So to go from here to here, remember you read from left to right, we go up 1, 2, 3, 4, 5, and we go over 1, 2, 3. So it's 5 over 3. As you notice, we are rising from left to right, so it should be a positive slope. So in this case, our equation becomes y equals 5 over 3x plus 3, right? Because when you substitute into y equals mx plus b, you get y equals 5 over 3x. Here we have a horizontal line. If we pick 2 points, doesn't matter what 2, we don't rise any. So our rise over run is 0 over really infinity, right? We're running infinite. So it's just 0. So and our b is where we cross the x-axis, which is -1. So our equation just becomes y equals 0x minus 1, which is just y equals -1. Right, over here, what's our slope? All right, our rise is pretty much infinite, right? And our run is nothing. So we're dividing by nothing, which means our slope is undefined. And our b is nothing, right? There isn't one. It's not applicable in this case. So in this case, our equation is just x equals -4. Because no matter what y is, x is always -4. All right, so that's a vertical line. All right, let's skip that. And I want to go to a question like this. Write an equation of a line given the following information. The line passes through the point 3, comma, negative 3. Okay, I'm going to start right there. Not even going to go any further. I'm going to go ahead and plot that point. So here we are, 1, 2, 3, and down 1, 2, 3. So here we are at 3, negative 3. Okay, then it tells us that the slope is 3, which is the same as 3 over 1, and that is our slope. So we don't have our b in this case. We don't have our y-intercept. Well, we can still go from this point and use our slope, right? I can go up 1, 2, 3, and over 1. I can do it again, up 1, 2, 3, over 1. Or I could go down 1, 2, 3, and backwards 1, correct? And I could graph that line. All right, so eventually, right, you see that it is going to cross the y-axis, but we can't tell from this graph where it crosses. But we could use y equals mx plus b, right? We already have our m. We already have m is 3, but we don't have b. But we have one solution. Remember we talked about solutions? This is one solution of our equation, or one solution of our graph. So we could take that. This is just 1x1, y1, and I could plug it in, right? And our equation should be true. When we substitute in a point on a graph, it should make the equation true. So I could substitute in negative 3 for y, and then substitute in positive 3 for x. And now I can solve for b. So negative 3 equals 9 plus b. All right, solving for b, I can subtract 9 from both sides. And so b equals negative 12. Does that seem reasonable? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, it seems reasonable based on our graph. So my equation now is y equals 3x minus 12. Okay? All right, I'm going to stop right there.